Good morning, everybody. We do have some icebreaker questions. It'll be up shortly, so make sure and fill those out if you haven't already. Welcome to the third installation of the Drones in the Coastal Zone webinar series. My name is Deborah Hernandez, and I'll be your facilitator today. My day job is Executive Director of the Southeast Coastal Ocean Observing Regional Association. With me is Chris Taylor as my co-host from Noaa's INCOS Labs. Good morning, Chris. He's going to help make sure we stay on time. Welcome both to returning attendees and those who are new to this series. The planning team's really excited about the broad interest in drones, and hopefully you're all looking forward to some learning opportunities and great discussion today. I'd like to draw your attention to the website noted on this slide. You can find background material, recordings of previous webinars, and research papers, lots of other helpful information about the series and drones in general. Please be aware that we are recording the webinar, and that'll be available for anybody to view later. We should have it up sometime later in the week. I'd like to take a moment to remind everybody of the goal for the series, which is to improve awareness of the emerging issues in coastal management, what the state of the science is, and also regulatory policies related to drone technologies. So our objectives are that you, as participants, will learn about drone operation best practices, learn about efficiencies in drone project execution, learn how to navigate the drone policy framework, become part of a drone operator network in the region, and also that will increase our capacity to use this technology. So next up, I'd like to thank our sponsors. We have several divisions of Noaa, the Southeastern Caribbean Regional Team, the National Centers for Coastal Ocean Science, the National Estuarine Research Reserve System, and also IUS, the Integrated Ocean Observing System, with two of its regional associations, SICORA, which I've already mentioned, as well as CARICOOS, the Caribbean Coastal Ocean Observing System. And finally, our technical experts in this endeavor, the Duke University Marine Robotics and Remote Sensing Lab. A special shout out to the planning team this has definitely been a labor of love. COVID impacted our plans, as I know it's impacted everybody. So thank you to the folks from SICORA. Here's our agenda for today. We'll be focusing on two topics. Our panel session will present information on incorporating training into your drone program. Then we're going to shift gears a bit and hear about UASs and marine debris to set up our breakout session, which is going to focus on using drones for various coastal hazard and damage assessment objectives. And then after the breakouts, we'll come back together and do a quick closeout of the meeting and finish with some evaluation polls. So before we jump in, you'll notice the polls there on the right of your screen. It looks like teleportation is winning out. Some great comments in the chat about which superpower is most useful and applicable to this drone session. So just keep it coming. Our objective today is to get into some of the details about how to get certified, qualified, proficient in UASs. What are the training requirements? What are the proficiency standards? We'll hear a little bit about some courses and curriculum and also professional organization certification. Please remember to type questions in the chat box, and I will pose these to presenters as we conclude the final presentation. So first up, we have Lieutenant Nicole Chappell. She's the Unmanned Aircraft Operations Officer at the UXS Operations Center UAS, which is Unmanned Aerial Systems Section. She assists groups getting started in UAS operations and supports existing operators by guiding them through the operation approvals process and assisting in airspace coordination. So welcome, Lieutenant, and take it away.
Nicole, I think you're still on mute.
Thank you. So with any UAS program, safety is important and integral, and one of the ways we achieve that is through training and proficiency. So today what I'm going to do is briefly touch on Noaa's current training and proficiency requirements, and then also on some changes that are occurring in Noaa and where we see that potentially going in the future. Currently, with Noaa, the majority of our operations occur under what's called the Wide Area Approval System. This is essentially an expedited way of us approving projects by generalizing the operations. Most things occur under 107 conditions, so less than 400 feet, visual line of sight. So when operations are occurring under that, we fall under these training requirements. The first of those requirements is a Part 107 certification. So that's a certification that you get from the FAA. You have to take a written test and get qualified. Once you complete that test and pass it, you get a certification card that you would send to our office to show us that you are a qualified UAS operator. The next requirement we have is manufacturer or equivalent training. So this is basically a way for you to show us that you've been trained on how to properly operate that platform. Once you have those two requirements met, the Part 107 certification and the manufacturer equivalent, if you're a Noaa employee, you send those two documents to our office, the UAS operations office, and we would draft a pilot and command designation letter for you. Our pilot and command designation letters are specific to each platform. So if you're flying a DJI Phantom, then that pick letter would say DJI Phantom. If it's an APH-22, it would say APH-22. Same with the training, it's all specific. Now, if you're a non-Noaa employee, so if you're a contractor or an affiliate, what we require is that you send us your Part 107 certification, your manufacturer or equivalent training certificate, and then a pilot and command designation letter from the agency that you work for. So this would just be a letter from them saying that they're authorizing you to act as a pilot in command for a Noaa operation and that you've met all their training requirements. Now, it's probably a little confusing as to what we consider manufacturer or equivalent training and what the requirements for that are. So we'll touch on that. For our training requirements, the training must have a written syllabus. So it needs to be something that you can, a syllabus that you can send to us that tells us what they're going to cover in that training so that we know exactly what's being touched on and what's happening in the training. It doesn't have to be word for word detailed what they're going to tell you, but it does need to let us know that they're meeting all of our requirements. The training has to be specific to each UAS. So if you want to get certified to fly an APH-28, you actually have to fly an APH-28 in the training. And the classroom portion needs to cover the specifics of that platform. While all platforms have similarities, there are differences that are important to cover in those trainings. The training has to have a hands-on portion. So you can't just sit in a classroom and listen to how to fly the platform. You actually have to go out and fly the platform. And then it needs to cover normal, abnormal, and emergency procedures. So this means, in general, if everything's working as planned, you should be able to fly it, no problem, and be totally comfortable at the end of that training. In terms of abnormal, if you were in a GPS-deprived environment, covering how you would operate under those scenarios, or in an emergency procedure, what you would do if if something failed as you were flying. So an important part is you get this training and you're ready to go fly, but you have to maintain proficiency. The training's no good if you just do the training and then you don't go fly the platform ever, because you'll forget all those little integral important things about flying the platform. So our office has proficiency requirements that we require of our operators. So we require 3 takeoffs and landings every 90 days. So that means, yeah, you could go out and do 3 takeoff and landings all on the same day, but ideally our operators are going out and flying these on a more regular basis than that, and they're not doing them all on the same day. We also require, so let's say that something happens, like for example, with the whole COVID situation, in a lot of cases people haven't been able to go out and fly. So obviously, if you haven't been able to go out and fly for 3 months, then you would be out of proficiency. Well, we need a way to regain that proficiency. So a lot of manufacturers have training simulators. So if you have a simulator that you can operate in, you can basically do some flights in a simulator and then go out and fly the UAS itself. If you do have someone, for example, if it weren't a situation where no one was able to fly and it was just like me personally, I wasn't able to fly for 3 months, but someone else in my office was able to fly, then I could use the other person could act as the pilot in command on the platform. So they would be the person responsible for the platform at the time I'm flying it, and I would go out and I would be considered what the FAA calls the person manipulating the controls. So I would have my hands on the controller, actually operating the platform, taking off and landing, completing my 3 takeoff and landings and my 3 flights. And that person would just be standing right next to me so that if anything went wrong, they could then take the platform from me and land it, and we would be still under our regulations okay in that sense. If no one in your office has proficiency, you can go out and you can do dedicated training flights. So you can actually go out and do some retraining to regain that proficiency. So as I said earlier, our office is undergoing some changes. We were under the Aircraft Operations Center. We're now under the Unmanned Systems branch. And along with those changes, we just recently hired a new trainer, Darren Goodbar. He just joined our office about a month, 2 months ago. And we're working to stand up our own training program. Right now, we're completely reliant on outside vendors, so either the manufacturer or a company that provides training on that specific platform. What we're hoping to do in the future is set up actual training for, one, how to work through our whole policy system, and then also on the platforms themselves. So we would actually have our trainer go out, do this hands-on training and classroom training with any operators that are wanting to get certified. Now, it's unrealistic. We have a whole lot of platforms, so it's unrealistic to expect that we'll be able to provide training for every single UAS that Noaa operates. In some cases, we'll still utilize that manufacturer or equivalent training, so coming from the manufacturer or an outside source. But the idea behind getting a trainer is so that we can start providing the service more readily to Noaa UAS users. Now, we're also looking at other potential programs in this, so potentially a train the trainer style program so that other people can help get new users certified. But all of that is still in flux. It's all still under discussion. The one thing we're certain of is that we do want Darren to be able to go out and provide training for our users on certain platforms. Generally, they'll be the platforms that are the most commonly used UAS that we see.
Lieutenant, you got a minute left. Oh, there you are. You're at the end.
Sorry. Oh, no problem. So anytime you have any questions about UAS, please feel free to reach out to the email you see on this slide. Our office is kind of your first contact for any questions of that sort. And today, obviously, we're going to have the Q&A at the end, so please feel free to ask any questions you have then. Thank you for your time.
Great. Thanks so much, Nicole. That was a great introduction to various training requirements. We're going to now shift over to Troy Walton, who's going to provide examples of regulatory and technical training curriculum. Troy is the remote sensing lead for Atolo LLC, a service-disabled veteran-owned small business based in New Bern, North Carolina. He flew UASs for the Marine Corps and is now interested in utilizing drones for advancement of natural resource management. So, Troy, the floor is yours.
Thank you very much. I just got to start by saying there's a shocking amount of correlation between what Noaa is doing and what the DoD is doing for the main project that I'm working on with Duke, with Mars Lab, and UNC Chapel Hill, the Institute for the Environment. So it is amazing to see it, and it actually makes a shocking amount of sense. And I can say this because I'm a prior service Marine, and there's a whole lot of things that I've done over the course of my 8 years that I was a Marine that did not make any sense. So it is great to see that, and I'll talk about some of those and highlight a few of them here in just a second. But in case you did miss last week when I gave a presentation on READY, the regional drone demonstration for installations and environment, Atolo is a service-disabled veteran-owned small business, and we do a lot of training-based, specifically in the unoccupied aircraft systems sector. So we have a couple different things that we have to do in order when it comes to developing our training curriculum that we now present to environmental staff on DoD installations. So part of that was coming up when consulting 14 CFR Part 107, which Nicole mentioned. That is the FAA's training standards. There's a 60-question written test that you have to go to a testing center to take, and that allows you to fly a drone and get paid for it, essentially. So in the DoD side, we have what's known as the CJCSI 3255.01, which is the Chairman of Joint Chiefs of Staff, and they have what's known as BUC, Basic Unmanned Qualifications. So, for example, I'm qualified to fly a drone in pretty much any airspace there is, so that's DoD BUC Level 4. And then we train to what's known as BUC Level 2, which allows you to fly in certain types of airspace. And basically just as you add levels onto the BUC, that allows you to fly in more restrictive airspace, essentially. And the whole purpose of BUC is to fly in. Over most DoD installations, you have what's known as restricted airspace. So not just anybody can fly through there. It's primarily used for military training. And that's due to military aircraft or artillery fires, anything along those lines. So in order to develop this, we used what's known in the ISD world, instructional system design, as the ADDIE model. So this is extremely boring, to be frank, and not the most entertaining, but it is what can make or break on how you are developing curriculum and whether or not it's a success or a failure in the end. So just as a quick run through, it begins with the analysis phase. You really have to decide, what are you trying to do? Who's the audience? Who are you presenting to? And then timeline is a huge one. So not just how long do you want the course to be, but how long do you have to develop it. Because the ADDIE model can be extremely long and drawn out, which is why we kind of adopted what's known as the agile model of curriculum development. It allows you just a little bit more flexibility when you're going through and developing the timelines and whatnot. The next step is design. So we're storyboarding everything that we wanted to come up with. So we have a wide breadth of what we cover in our course. Everything that's in Part 107, so aerodynamics, weather, airspace, what else? Drawing a blank, but we have, I think, a total of 12 modules that we teach. It's a 2-week-long course. But then, as Nicole mentioned, we also have to figure in the last bullet there, live flights. So Part 107 does not require any flight time, which has kind of proven a problem in the commercial UAS industry. You can study for a couple weeks. It's really not that intensive, and go pass the Part 107 exam at your FAA testing center. Then the problem is you show up in the field and you have no idea how to fly your drone, how to check the weather accurately, or any sort of safety factors are not into your flight plan. No crew resource management. But the basic unmanned qualifications do require you to have live flights. So that is one of the biggest things that I noticed that Noaa is doing in correlation to DoD, which I think is extremely important. So we basically have a week of flights and then a week of classroom time for our 2-week course. We certify people at the end after a 60 question test, and we give them what's basically just over the course of the 2 weeks flight evaluations, not formal, but as Nicole mentioned, safety is paramount with all operations, so we are highly geared towards that. I kind of skipped around a little bit there, but the development phase is really where we're kind of making the meat and bones of the course. So you see a little snippet of a VFR sectional there. That's part of the airspace class. Weather, and then we train to the EBX, which is one of we mentioned the mission kits last week. That's one of the aircraft, and then we also fly the Prioritization thermal. And then in the end, that gets you what you see there, says United States of America on top. That is a picture of a Part 107 license. After you pass the test, we ship you one of those, or the FAA does, and then you are a certified drone pilot. And you can go out and make money with your flights. Implementation is the next phase. This is actually going through and delivering the courses. So over the span of about 8 months, actually, we're giving a total of 5 different courses to Marine Corps Installations East. All focuses on the operational side. As you noticed, all the courses that I mentioned were all related to flying the drones. But then there's an important aspect of what do you do with that information once you are done with the data collection. And that's a little bit about what Dave is going to talk to next. And that's what we rely on Duke and UNC for in regards to processing data with Pix4D Mapper, tying it into ArcGIS or any other kind of GIS platform. We did do a full course rehearsal, which was really nice. The evaluation phase, what you see there is the last step. It actually takes place in every step of the model. You're always constantly evaluating each phase as you are developing. So we had a couple of undergrads that the Duke Marine Lab were able to loan to us, and then Justin Ridge, who is on the call here, is a research scientist for Duke. He was in the course, and we got a lot of valuable feedback. So we made quite a few changes before we actually gave the course for the first time, the actual live course under the Confirm and Ready projects. And then now each iteration, we make a few improvements from the feedback that we receive from students in our course critiques, which is also a part of the evaluation phase. And that is all I have for the curriculum development. I'll be looking forward to any questions you all may have towards the end. Thanks.
Great, thanks, Troy. That was another nice introduction into what a training program can look like. Up next, we have Dr. David Johnston. He is an associate professor of the practice of marine conservation and ecology at Duke University. And more important for our purposes here today, he's director of Duke Marine Robotic and Remote Sensing Lab. And he's going to show us and talk to us today about environmental and ecological drone systems training. Welcome, Dave. And I see lots of questions coming up in the chat, so please keep them coming, and we'll get to them after our next two speakers.
Hey everyone. Hey, thanks again for joining our session. I'm excited to be able to be here and talk to you a little bit more about our sort of science training program. And I'm going to share my screen so that you can get a look at what this sort of looks like on our end of things. And hopefully you can all see that now. As opposed to the first two parts of this panel, I want to talk to you not about getting students to the point where they can fly and where they're proficient and qualified to do that, but instead talk a little bit about the science training aspects of what you might want to do in a program, where we work on trying to get students to understand more about how drones work, how they collect information, the different kinds of sensors, how they're being applied, so basic introduction to those kinds of applications, and also the best practices for doing this, and not just in the case of the operational best practices, but thinking about other types of issues like legal and ethical issues. And so these are all components of a modular training system that we have, and that we've been developing a lot more in depth over the past 8 to 12 months, partially because of our push towards more remote teaching. And so the screen that you're seeing right now is actually our learning management system. And I thought the easiest way for us to be able to do that, to show you this, is to actually take you through what a student might see as part of one of our classes. And so when the students log on, they're able to access all this material. There's an overview for the class. There's also the syllabus for the course. And in this case, the syllabus, I think we'll be able to provide for you as background for the class, but it essentially describes to the student what they're going to get as part of this training. And in case of our current online practices, the students are going to learn about those platforms and capabilities, different types of sensors, operational considerations for various environments, mission planning. Some of these things are going to be covered more in the webinars in the future. And so I won't touch very much on those things, but it's important for you to see how we sort of structure what we're doing to try and train students to be good scientists when they apply drones for their particular application, right? In the case of this online learning environment, we will have an introduction that essentially gets students excited about what's going on. We're able to embed videos, and we also provide navigational information through walkthrough videos that will allow students to learn how to actually access all of the stuff that I'm showing you. We teach them how to read scientific articles because we rely very heavily on science as the core. But we also use a textbook, and in this case we use a conservation drones textbook by Serge Witch and Leanne Pincoe, two founders of conservation drones, as part of the resources that the students will make use of as they move through their course. And on the left-hand side, there's a series of tools, and basically the course can be set up in such a modular way that you can pick and choose the types of components that you might want to include in each section. So in this case, the first session that the students would be involved with would be basic understanding of how drones are applied and how they work and the anatomy of a drone. And we've shared some of those videos with you already. But essentially we set out those learning objectives, and then each one of these sections is populated out with information that students are able to make use of. In some cases, we use more inspirational videos like TED Talks that are available, which can be a really great source for teaching students about things, and they're often quite inspirational. But we can also link them directly to the materials that are part of their, what they'll be assessed on. So, for example, they can load up, individual papers here in the learning management system and go through and annotate them and essentially study them and share those annotations. So the system is designed to be very sort of focused, but it's also modular. So we can pick and choose which types of modules we would want to present for, say, a separate client. If we're teaching an undergraduate course, we may present different information than we might be for a graduate course. Or if we're doing executive education, we may be providing, access to a different set of materials. We start off with drone basics, then we then move into power control and systems and sensors. So we provide modules on how drones are controlled, how they are powered, how photographic systems work in cases where we're using gimbals. We explore both passive and active sensors for doing this type of work, and then also include background information to resources such as NASA's ArsNet training program, where they have these fundamentals of aquatic remote sensing type capabilities that allow students to go even deeper into the depths. So we include not just our videos and the information that we're focusing on, but also that's produced by the experts in the field. We'll include a series of different applications. Drones can be applied for behavioral ecology, for photogrammetry, abundance estimation, and integrative ecology. These are different types of science applications. We can also do habitat mapping, ecosystem restoration, reconnaissance and surveillance, and also including new things like the fact that we're about to put we're putting a rover on Mars that might have a drone that will have a drone that might fly. And so this provides the opportunity to give real world applications of how these drones are being applied. And then after that, we actually get them working with the data. In the remote sense, they actually are able to remote into Duke, spin up a virtual machine, and actually conduct labs with drone data. So for the context of this particular webinar, they'll actually log in and do a coastal change lab where they work with structure from motion and actually look at how a coastline might be changing. One of the things that you'll get a chance to look at is some of the resources that we use in our photogrammetry work for measuring whales. And we also have labs where students actually will learn how to build a convolutional neural network and actually train it and then run it to detect things like seals. So these students get hands-on working with those data as well. And then the last thing I want to touch on really quick is the fact that we also teach an entire section on best practices. And so some of that has been discussed previously in the first two presentations. So we do provide training on maintenance and record keeping and metadata, and we rely heavily on Otolo now for our, teaching our students those operational parts that get them to Part 107 or the other levels that they need to be at. But we also cover best practices when it comes to technology and data, which are things that we're going to talk a little bit more in future webinars. And perhaps most importantly, we delve into these legal and ethical best practices. So how do you fly drones legally and ethically in a coastal zone where you have mixed property access, you have people, and also a little bit about the social and environmental justice aspects of using drones, not just here in the US, but in other countries, and so cover those types of things as well. And you're going to hear again more about those things later on as this webinar series of webinars progresses. And so our goal, actually, as we move forward, is essentially to take this kind of information and turn it into essentially a series of modular courses that we can apply in an executive education type context, where we can work with a client and provide this type of information that's targeted for their particular sort of context. So in the case of an agency that might want to learn how to use drones for science practices, we can tailor it. An NGO, an undergraduate class, or a graduate class, those types of things. So even like alumni courses we could actually put together with this modular approach. So anyways, I think that's probably where I want to leave it. I'm going to stop sharing my screen and pass the baton on to the next presenter.
Hello, everyone. I'm John Combs. I'm with the Noaa Office for Coastal Management in Charleston, South Carolina. And today I'm going to be talking about Asprs certification. So the first few presenters here provided an excellent lead into this discussion, because we've learned about some of the legal requirements and the hands-on training you need to do to be qualified to be flying a UAS. And Dave talked about some of the important parts of the ethics and the actual applications and the real world experience that you need and you really should have to be a good UAS operator. So that's what I'm going to be kind of covering with my discussion here. So for those who do not know, Asprs is the American Society for Photogrammetry and Remote Sensing, founded in 1934. It's a U.S. member organization of ISPRS, which is the International Society for Photogrammetry and Remote Sensing, founded a bit earlier in time. It encompasses many disciplines within the mapping sciences. So it's not just remote sensing, it's not just GIS. It covers everything from the sensors to the applications to standards development, protocols, ethics as well. And it's a collaboration from three main sectors, that being the academic sector, does a lot of the education and the research involved with remote sensing and GIS and geospatial sciences. The government sector tends to bring in more of the policies you see and the standards development and some of the larger programs that are out there. And then we have the private sector, the practitioners who actually put all this stuff into use and actually drive a lot of the what's developed through the academic sector and through the government sector. Within Asprs, there are several technical divisions. These are listed up here, so it has a wide variety of background and experiences. It's not just one single topic of remote sensing. It's sensors and platforms, to the processes and methods, to the actual analysis through GIS and remote sensing, LiDAR. The newest division is actually focuses on UAS. And then additionally, one that's kind of important that, again, has been talked a little bit about so far is that professional practice. That's bringing into the standards and the ethics and the continuing education that you really need to be a true professional in the field. So Asprs certification program started pretty simply in 1975. There was the board of directors just approved a basic certified photogrammetrist, the very initial ones, the first certification program. It advanced up to 81, where they added a couple more categories. That is the certified mapping scientist. You can do that in remote sensing or GIS. In 1998, it became more formalized with the board of directors bringing in a formal examination process for all the certifications. And then through a very large concerted effort by the organization, Asprs, the program, it received accreditation from the Council of Engineering and Scientific Specialty Boards. So it put some actual weight and some true technical merits and methodologies behind the certification program. Within Asprs, the certification program, you can be certified through 5 different fields that are shown up on the screen. The newest one that we have added is the UAS mapping down at the bottom. So it's photogrammetry, remote sensing, GIS, LiDAR, and UAS mapping. So we've heard it quite a bit so far, and most everyone's going to be familiar with the Part 107. Those are your licensure. Those are things that you legally have to do in order to fly a drone in certain situations. A licensure can be, at the most basic level, be thought of as a minimum level of competence. Kind of like you get a driver's license, meaning you passed a test, you are not a threat to society, hopefully, that you can drive. You know the laws, you know what you're supposed to be doing. Whereas a certification can be thought of as a little higher level of professional achievement. And a certification process, such as like the ASPRS uses, a user or an individual is undergoing a voluntary process, being reviewed and recognized by one's peers. It's often by a third party or a private organization. So it's not just a legal requirement. It's going one step kind of above and beyond what's the minimum required needs. The certification within ASPRS is made up of 3 main parts, such as practical experience, what you've actually done in the field. You have to have references. They can vouch for the work that you've done and the type of professional you are. They kind of vouch to your experiences and your ethics and how you do your work. And you also have to take and pass an exam. So the overall cert objectives of ASPRS Certify is, again, it's to identify and recognize those users who go above and beyond the minimum legal requirements. So you undergo appraisal by your peers, you pass a written exam, and you meet these requirements that have been established by the society and been accredited by a formal organization. It actually, it can provide a basis for if any allegations or complaints that may come up resulting of a UAS flight, because you have your legal standing with the FAA 107, but this also says you went above and beyond that. You've been recognized by your peers, and it can help provide you some backing in case there's some complaints against you. ASPRS definitely encourages people to work towards certification, as a goal for personal achievement to keep growing. And the certification, and it's been talked about before, especially with the Noaa process, is you have to maintain it. The ASPRS has a recertification process to encourage people to continue to grow, to learn the new technology that's changing so quickly within this field especially. And it isn't open to all qualified individuals. You do not have to be an ASPRS member. You just have to pass the qualifications. The certification can occur on 3 different levels. You can become a professional, a technologist, or a geospatial intern. So as a professional, you have to have at least 6 years of geospatial experience, with 3 years being in the area of specialty. You can become a certified photogrammetrist or a mapping scientist, and you do have to take a test. The technologist is the next step down, which you have to have 3 years of geospatial experience, 2 years being in your area of expertise, and you also have to take a test as well. And then you also have the geospatial intern, which is geared towards those getting started in this field. So a lot of times these will be the college students. You have to have 12 college credits, and you also have to take a test. But it's a way to encourage people to get into the field and help grow the field. The process, there is an application form on the website provided. There's also on that website, there's a full manual which is available in the files share pod over on the right. It's an all digital process now that you go through online. You do have to acquire 4 references, and that's they can validate what you've done and what you're vouching for on your application. After everything's submitted, there's an actual committee that goes through and reviews all the submitted material. They're looking at your experience, your activities and service to the profession, what skills you have, how long you've been doing it, what level of responsibility you've had throughout your time of work. And if they approve, or once they approve your application package, you do have to sit and take a proctored exam. Again, this is just what the website would look like. So it does have full information as to the guidelines, and actually how to apply is all directly online. And for the recertification process, you can keep track of your what's required. There are costs associated with it. Again, you do not have to be an ASPRS member, but by being a member, you do get a $150 discount at the scientist level or the technologist level. And finally, what we've talked about before, it's that continuing to grow, so recertification. Your certification is not for life. You do have to reapply with references, and you do have to submit, validation and proof that you have continuing education or professional experience. That can be in the form of attending this workshop counts, or giving presentations at conferences, or submitting peer-reviewed articles, or reviewing articles that have been submitted in other journals, or mentoring people. Those all count towards recertification process. It's that continuing involvement in the field and continuing professional experience. And as you see down below, the mapping science is good for 5 years. A technologist is good for 3 years. With that, I will wrap up and leave it open. I guess we're going to be moving into the next panel discussion time. Sure.
Thanks so much, John. That was a great presentation, and I think we've been able to see a nice range of training programs from our 4 presenters. So there have been a number of questions in the chat. I'm going to try to walk through them, and we're happy to get more. We have about 10 minutes for this portion of the agenda. So Nicole got a bunch of questions, and she's done an excellent job answering them in the chat. I'll run through a few of them. There was a question about how many operators in the Southeast have been certified, and Nicole answered there were approximately 20 from various different offices within Noaa. As to when Noaa might have their training program set up, that's a little uncertain. They're working on sort of the book work, but because of COVID, there are a number of questions about when they'd be able to do any of that in-person training. There was a question around, are the requirements the same with other federal agencies as they are at Noaa? Probably there's some similarities, but I think Nicole's question answer was that you'd need to double check. And then there was a question about whether from Brian, who's with a small company who has their own training program. And Nicole, if you're available, maybe, I'm not sure if this question got answered, would Noaa recognize their training program as being valid for use of UASs for Noaa projects?
So in that case with the training programs, we look at all of them the same way. So they would be eligible to conduct training for Noaa employees. They would just have to meet those training requirements that we were saying. So they would have to have a written curriculum. It would have to be specific to whatever UAS they wanted or the operator was wanting to get trained on. And it would have to cover those abnormal, normal, and emergency procedures.
Great. Thanks, Nicole. There was also a question from John Quinlan about whether parts of the training could be provided remotely. Are y'all thinking about that?
So currently, no, we are not allowing remote training due to the hands-on nature and the needing to actually operate the platform, work through the checklists to pre-flight. And so currently, no, we are not doing virtual training.
Okay, thank you. Next, I'm going to move to Troy. There were a couple of questions. One was related to BUC certification and whether that's required to fly in any restricted airspace, such as airports or at other DoD installations. And Troy, correct me if I'm wrong, but I believe you said no, it's not required necessarily, but there are significant cyber security requirements that have to be met.
Yeah, you were correct with that. it's kind of a gray area. You can fly in restricted airspace without the buck requirement, but there are a ton of cybersecurity problems in that you have to kind of get over the hurdles of that. But a DoD employee flying on a DoD installation does have to be buck certified.
Great, thank you. And then there was another question about the ideal method for checking weather conditions for drone ops, and you had a few great suggestions, including aviationweather.gov. So I think probably some of it sounds like was personal affinity, but appreciate you putting those resources in the chat. Now I'm going to just check in and see if any of you would like to unmute and ask, or maybe you can't. Are there any other questions for any of our presenters?
Deborah, there's a new one from Pedro. In general, for non-aerial drones, what is most important in terms of operations and missions? And I guess that's for any of our presenters.
Maybe I'll send that to Dave or John and take Nicole and Troy off the hot seat.
So I'm contemplating the question. So for non-aerial drones, what's most important in terms of operations and missions? Yeah, I mean, I guess maybe I need to know a little bit more about, you know, what the question is trying to address. There's certainly, from what I understand, not nearly the same kind of framework for, you know, sort of managing and, you know, constraining operations for ROVs and gliders and those types of missions. But I you know, we do use those, but we haven't been made aware of those types of regulatory things that we need to be working with.
Yeah, Deborah, Chris Taylor here. So I'm aware of a certification program that is being offered by University of Southern Mississippi on uncrewed marine systems. So that could be the surface or underwater. We operate AUVs and ROVs and ocean gliders, and I think it's more of an internal process of maintaining proficiency so that your understanding of the engineering and maintenance requirements for the systems. But I'm not yet aware of requirements for training that would be in the same vein as the air systems, as far as you know, where you operate the vehicles, how you notify other operators in the area. That, like Dave said, it just doesn't seem to have the same framework as air systems, unless Nicole and OMAO have other insights.
Thanks, Chris. Yeah, based on my limited knowledge of the glider operations that SCORE supports, these questions that come up around licensure, et cetera, are not being asked of glider operators. And thanks for that reference to that training program at University of Mississippi. I think it's going to be a great resource for the underwater glider operators and other ROV operators. Okay.
Deborah, I want to acknowledge that we had a participant raise his hand. Cornelius did. We don't have microphone access at the moment for our participants. So Cornelius, if you have a comment or a question, please do put that in the chat and we will get it to the right people. And if we're running out of time on Q&A, they can follow up with you afterwards as well, or maybe on the break.
Thanks, Steph. So Cornelius, we'll give you another minute to maybe type a comment or question. And I see that Michael Card mentioned some work the Coast Guard's doing looking at unmanned marine operations. but it sounds like there's not likely to be a license requirement, at least in the near term. All right. Well, I'm not hearing any further questions. I'd like to take a moment to thank all our panelists. Really excellent presentations. We're going to, let me advance the slide, take a virtual coffee break, and we'd like for you to be back promptly at, I'll give you an extra minute, we'll say 11:05, and we'll have one more presentation before we move into breakout sessions. So thanks everybody, and I'll see you back in 6 minutes.
Cornelius, I see your question for our presenters. I'll just say it out loud here in case any of them happens to be hanging around and can answer in the chat or verbally. You were asking if there is a list of acceptable drones. Are you referring to a specific certification or course or something else?
Is the list of acceptable drones you're asking about based on Noaa requirements or based on the legislation that's coming out currently with the American Drone Security Act?
Nicole, I'm not seeing Cornelius type anything else right now. Maybe you could just answer both.
Try and answer it in the chat, and when he responds to the chat, I'll answer it there. Thanks.
Sounds great. And there's also, I do think that this is related to the American Drones Act. Paolo has asked, in the past there was a concern about the use of GJI drones. Is that still a concern related to linking to China servers?
So the American Drone Security Act it's still potentially, there's actually there's a Gallagher amendment to it. There's a couple things that are getting looked at, and those requirements haven't been actually ironed out or signed into effect yet. If they do get signed into effect, then that will affect all of that stuff. In Noaa, we still are currently operating DJI products until legislation comes out that says we can't.
Great, thank you.
That legislation would affect more than just the DJI products.
Hey Stephanie, this is Troy again. I can add to that as well. For DoD, I know Department of Interior and I think a couple others are actually, they are banned for DJI, that is, are not allowed to be used. And then DoD has even gone as far as to, I think it was maybe a couple months ago, they came out with what's known as Blue UAS, and it's 5 American drone companies that are now approved to be utilized on DoD installations, and I think it may even come down eventually to it has to be one of those 5. But anything that's like European drones are usually okay. Right now they have interim flight clearances, IFCs, and there's a big long list that DoD approves, but I do think that's probably going to get more restrictive as we progress.
Thanks, Troy. That's great information. And if there's any sort of web link or anything that you can put into the chat where folks can find those lists, that would be fantastic. If not, I understand.
Top secret, double classified, triple threat, but I'll see what I can find.
Thanks, Troy.
Okay, Stephanie, I am back. Let me advance slides here. Whoops.
Sure. Okay, we have like 5 seconds left on the timer. I'll go ahead and switch over for our lightning talk.
Welcome back, everybody, and thanks for staying with us. Next up, we have Peter Murphy. He's the Alaska Regional Coordinator and Remote Sensing Lead for the NOAA Marine Debris Program. He's worked with the program since '07, starting with surveys for hurricane debris in the Gulf of Mexico, then shifted to the beautiful state of Alaska in '09, and through all that work, he's been utilizing remote sensing technologies and techniques. So he's going to present today on marine debris and UAS's goals, efforts, and opportunities. Thanks, Peter, for being here.
Thank you. Well, thanks very much for the opportunity to come talk with you guys today, and I'm already learning a lot myself and hearing more, and always great to hear what's going on. So I'm going to get right into kind of the use case of marine debris and UAS, which is something we're excited about and have been exploring. I already hear from some folks connected to groups we've been working with, which we'll hear more about in a minute. So first, just kind of, talk a little bit about kind of our goals, our current and future efforts. I'm presenting on behalf of myself, as well as Amy Uren, the Chief Scientist for the Marine Program, Tim Batista with NOAA NCOS, and then Chris Parrish from Oregon State University, who's working on a project that we'll highlight a little bit later in the presentation. So first of all, just a little bit about kind of our overall remote sensing approach. As with many other topics, we're looking at taking a top-down approach, and I say that no pun really intended, but the combination that we're really trying to understand debris location and quantification using a variety of tools. Obviously, satellite, then manned aerial, and then UAS, where we're focusing here. But I also do want to highlight that we also do look at surface surveys, either from vessels in the marine environment or from people walking the beaches, and that each of those answers different questions. And so UAS is a valuable tool in our toolkit and a growing one within that overall approach. So the goals of our detection efforts are really to get data, of course, collect environmental data about the abundance, how many debris items there are, and then characterization and composition, what kind of debris items they are, based on type, size, all sorts of different variables. But really those are the key things we're trying to gather. We can use that information for multiple purposes, but one of those is operational prioritization. So we're looking at, if we're going to go into an area and remove it, how much debris is there to remove, and how should we prioritize based on quantity? Or if we're looking at sensitive habitats, is it worth going into potential disturbance that might cause to get the debris out based on the amount or potentially the type, if there's a specific type of concern for impact. And also those combined can lead to policy guidance. So, if there's blank type of debris from blank sources present, and so we're going to do what? And so those aren't decisions we make, but data that we gather can inform policy decisions. Now, a few detection challenges and needs. Some of these are very common to different items outside of marine debris, but a few I'd highlight. So first, encounter rate. Debris concentration is often unpredictable and variable, particularly at sea. So we don't necessarily have a really defined or expected encounter rate. It can be very high or very low. But a few I want to highlight specifically is debris composition. Because debris is very diverse, it's got, we're talking about different size, shape, color. You can everything from a plastic water bottle to a fishing net and microplastics, all sorts of things. We can't tune our sensors or our analysis techniques to any one type of debris. And also detection versus identification, that links into that noting the presence of something versus identifying what the anomaly is a big gap or a big jump. And that especially is true when we're not trying to tune or can't tune to any one item. So a few example projects that I want to highlight are one with working with the Rachel Carson Reserve and Duke University, so we're hearing from them on debris detection and prioritization in sensitive habitats. So that aligns with what we talked about, where you're looking at where can you remove debris, so you map the debris and understand what's there, and then also what can you do about it, so understanding whether it's a good candidate for removal activity. Northwestern Hawaiian Islands, similar activity, where we were looking at debris detection for removal, targeting feasibility in complicated coral environments, so areas where it's very logistically complicated and time intensive and effort intensive to get in to these areas through kind of a maze of reefs. So is there enough debris to merit going in there operationally? And then Pribilof Island, so looking at shoreline debris quantification, how much debris is there, and then detection and prioritization in that sensitive habitat. So again, is it worth it? And so you can kind of get the picture that UAS is a valuable tool, especially in these sensitive habitat environments where it causes less impact or disturbance. So highlighting one more project, which is the Oregon State NCOS project. So the question we're dealing with here is, again, trying to get at that issue of detection versus identification versus quantification versus classification. So actually being able to see something, then knowing what it is. And then also that diversity of object and target. So the goal here is to create a payload evaluation and selection scheme, define data acquisition parameters, and automate detection of material type classification. So try to find ways to use machine learning and other steps to be more efficient in that. And ideally come out of this with a modularly deployable algorithms and approaches, meaning that these are going to be platform agnostic tools and techniques that other groups can utilize on different platforms, different UAS systems, aircraft, and with different techniques. So the techniques we're utilizing here are polarimetric imaging, and I'm not a remote sensing sensor designer, so on that element, but measurement and interpretation of polarization state of the light waves. So in combination with spectral imaging and spectral analysis, you can get a much better picture of what type of objects are. You can kind of see an example of this as well as in the previous. The signatures that come back can be more signature. And I know I'm just at the end here. Phases and actions of this, and some machine learning processes as well, building on existing techniques. And the phases here are data testing, so applying to test data sets in the lab, and then controlled field tests, so applying the techniques to debris that's intentionally placed so we know what's there, and then last but not least, validation tests, applying techniques to in situ debris. So with that, I'm at the end of my time, so any questions?
Great, thanks very much, Peter, and I know that was a quick overview. You did a great job and talked about some of the technical questions that haven't come up yet. I'm looking at the chat and I'm not seeing any questions yet. I have one quick one. Is the marine debris program building the capability at the national level to do these sorts of searches or projects and then deploying to where needed, or are you building regional expertise to fly these sorts of missions?
Good question. I think the short answer is we'd intend for this to be available nationally, but one key item of clarification is that, in the Marine program, we're not, we don't buy drones, or we don't have the intention of building our own drone fleet, because a lot of the work we do is with and through partners. What we're tending to do is to build the knowledge within the Marine community of how to utilize drones, so that this protocol or other protocols like that can be utilized or documented. So then if some group wants to work on marine debris and they get a grant from us or from someone else, they're not reinventing the wheel. They can do things the most efficient way. And especially with UAS, where there's a lot of development happening rapidly, defining those best practices can really create significant efficiencies, rather than each group trying to sort of iteratively advance in a slightly different direction, but with a lot of overlap. So short answer is, national would be the goal, but we're not planning on necessarily having a national capability or fleet of drones to check out or dispatch to address issues. This would be more about the practices and protocols.
Thanks, Peter. Great answer. And
Let's
makes perfect sense.
Do you want me to answer questions, or do you want to choose?
Go ahead. So you had a question.
Peter, are you involved in all stages of a project from detection to cleanup? So yes, in the case of Marine debris program, we typically, if it's a project we're directly involved in, we would be actively involved throughout. And some projects require or integrate detection, others don't. If it's a removal project, they may know where the debris is, so it's really about the removal. Or if it's a research project, they may have different aims, so they're not integrating UAS. But if it does have a UAS component and Marine program is sponsoring it, we would be involved throughout. And generally, we also try to just keep an eye on what projects, in literature and kind of community of practice are utilizing UAS or other technologies we're tracking or trying to keep an eye on, so that we can just be up to date on what's being done. And then for detection, do you use the imagery or also LiDAR? We primarily use imagery. We have looked at LiDAR, but we found that just for the specific use cases we're looking at, again, getting at debris differentiation and quantification, visual or imagery seems to be better as of now. But again, there's so many technologies that are, as techniques evolve and the technologies evolve, we're not, we wouldn't say that LiDAR is not applicable. It's just that it hasn't been our primary utilization at this point.
Great. One more question about using rovers.
Yeah, I don't know, I'm not familiar with the Windows paper on a beach rover to measure light pollution, but I am, so using robots to travel on the shoreline be used as well. Short version is, I think we'd be interested in those sort of technologies. However, it's always a matter of what technique are you replacing and what's the efficiency you're gaining. In the case of UAS, oftentimes it's the cost barriers for entry are lower than manned, and also you're causing less auditory disturbance, so that you can also get into more sensitive habitats without risk to the habitat of the species or to a person, the pilot. So you have a clear benefit there. For shoreline surveys, it'd be kind of think what is the additional benefit versus doing either aerial survey or a ground survey. But we're open to all technologies. We've used unmanned systems, both aerial and UAVs, so subsurface systems like the REMIS, that sort of thing. But it's a matter of what benefit do you gain, or sometimes if you have access to that technology, how do you handle it?
Great. Thanks so much, Peter. Thanks for the questions. If you have additional ones, just please put them in the chat, and we'll make sure that Peter gets those. So at this point in our agenda, participation in the breakout sessions, we had excellent note takers capturing all your great thoughts. We would like to ask you to take just a minute or two to fill out the evaluation poll. The notes from the breakout groups will be projected at the end of the meeting for anyone interested in viewing. The notes will also be part of the meeting report. We are at the halfway mark in this series, and so we welcome all feedback on how we can make this more useful to all of you. The next session is Thursday, October 22nd from 10 to 12. focuses on the regulatory, legal, and ethical considerations for drone operations. You'll see that we have a panel scheduled, Q&A, and plenty of time to answer lots of questions from our audience. So thank you for being here today. Special shout out to my co-host, Chris Taylor from Noaa INCAS, and Steph Robinson from Noaa OCM. Hope you all have a great day, and we'll see you possibly on Thursday. Steph, anything you want to add? Sorry, go ahead.
Nope, that's okay. Thanks, Deborah. I will leave these polls open for the next couple of minutes. It looks like Kristen Ransom indicated that in her breakout session, there was a question to pose to the group, whether anyone is aware of the use of drones in offshore fisheries research. So if anyone is still on the line and can type into that in the chat panel, or if any of our presenters are still on and want to come off mute, you can answer that.
Yeah, thanks, Steph. Looks like we're getting a couple takers on that question. And it definitely looks like there was some work done in the Northeast Fisheries Science Center using drones to characterize tuna schools, bluefin tuna. Thanks, John. And if Dave or Justin, someone from the Duke Lab is on, I know they've possibly had some experience as well.
Yeah, most of our offshore stuff has been focused on marine megafauna, so sea turtles and whales and seabirds at sea. We haven't done directly work, but I know there's interest in also doing a lot of schooling fish work offshore here. Even things like menhaden are things that people are starting to work on now in Noaa.
Great, thanks. All right, so I'm going to officially close the session from an audio perspective. Thanks again to everybody. Staff will have things open for just a tiny bit longer, and hopefully we'll see you all at the next session.
Thanks, Deborah. I'm going to close out the polls now. It doesn't look like many new responses are coming in, and that will thank you all for your feedback on those, and this will give everyone the opportunity to check out all of the notes from the various breakout sessions. I will leave this up for about 15 minutes so folks can scroll through. Do note that if you have something you'd like to add, you can't type in the notes pods at this time, so please type any additional input you may have into the chat panel.